Hello everyone, welcome back. This is Engineer Hussein Wasabi. So in this video, we'll be looking at the classification of materials in material science and engineering. So before we get to it, don't forget to like and subscribe to the channel. Now, I want you to understand one thing. Classification of materials in material science and engineering will provide you with a solid foundation in understanding the different types of materials and their properties. So material science and engineering, in general, I would say is a fascinating field, and it plays a crucial role in the development of new technologies and innovations in our day-to-day lives. So to fully understand this course, it is very important to comprehend how materials are classified based on their atomic structure, composition, and properties. So let's try and understand what I mean. When you look at material science, you're looking at the study of the relationship between structures and properties of materials. On the other hand, if you look at material engineering, you're looking at the study that involves you creating, or to term it better, engineering the structure of a material to create a specific set of features that are based on the structure-property connections. So, as engineers, we can convert materials into goods that society needs by using the knowledge that we get from the material science and material engineering. Now, this in turn describes the material knowledge spectrum. So, what we're trying to say is that material science will give you the knowledge about the structure and properties of the material. Now, once you acquire that knowledge, that's when you can now engineer or create what you want that will satisfy the needs of the society at large. So that is what we're calling material science and engineering. Now, let us understand clearly what we mean when we look at or define material science using terms like structure and properties. Now, when it comes to structures, the structure is defined to be the arrangement of the internal components of a material. So structure just talks about how the internal components of a material are actually arranged. If you look at the types of structures we have microscopic, microscopic, and subatomic structures. Macroscopic structures, when we talk about these structures, we're talking about structural features that can be seen with the naked eye. But if you look at microscopic, on the other hand, we're looking at structural features that cannot be seen with the naked eye. Then if you look at subatomic structures, these are structures that contain electrons within individual atoms, as well as the interactions with their nuclei. So let's understand that. So structure just talks about the arrangements of the internal components of the material, and we have the macroscopic, microscopic, and subatomic. If you look at property is the response of a material to something, in short. Because all materials are subjected to external stimuli that leads them to react in some way. And this defines a material's property. For instance, a specimen subjected to stress will deform, and a polished surface will always reflect light. So in terms of the nature and strength of the reaction to a particular imposed stimulus, a property is a material's behavior or response to that same thing. So therefore, we can actually state that the definition of property is given without considering the shape and size of a material in question. So we're just looking at how the material responds to stimuli. Now, property can be grouped according to the material at hand. So in most cases, we look at how we can group solid material properties. So let's look at grouping of solid material properties. We'll start with the first property, which is the mechanical properties. Now, the mechanical properties are characteristic of a solid material that explains how it behaves when subjected to external forces or stresses. Now, common examples of mechanical properties, we have strength. Strength is just the ability of a substance to sustain external forces without permanent deformation. We have several types. We have tensile, compressive, and shear strength. Stiffness is just a resistance of a material to deform when subjected to a certain amount of force. The Young's modulus and the elastic modulus are some of the ways we can actually quantify it. We have other examples of mechanical properties like hardness. Hardness is just the capacity to withstand surface indentation or penetration. When you look at ductility, you're looking at the ability of a material to deform under tensile stress, without fracture. So other mechanical properties are also brittleness. It's like the exact opposite of ductility. Now, when it comes to understanding mechanical properties, it's quite important that you understand what it is, to be precise. You're looking at how a material behaves when subjected to some amount of force. So once you understand what mechanical properties are, it is quite easy for you to understand the examples that are associated with it. Because once you just know that you're looking at the behavior, how a material will behave when subjected to some force. Let's say you hammer a material. What would be the response that the material creates as you are observing it? Yeah, the response will be the mechanical properties. That's why we had to look at strength, stiffness, hardness, ductility, as well as brittleness. Yeah, these examples of mechanical properties will be explained in details. The time we'll be looking at mechanical properties in general. Now, let us also mention one last example of mechanical properties, which is regarded to be toughness. Toughness is just simply a combination of ductility. It assesses a material's ability to absorb some form of energy and plastically deform before fracture. These are not all the examples of mechanical properties we have. There is quite a number, but these are the most frequent example of mechanical properties. All right, now moving on to electrical properties, we're looking at the behavior or characteristic that is related to the flow of electric current or the presence of an electric field. Some common examples of electric properties, we can talk about conductivity. Conductivity talks about the ability of an electric current to flow through a material. We have conductors that allow electric charge to travel easily. And then we have the opposite of conductors, which are called insulators, and they do quite the opposite. You'd find that insulators will have a low conductivity and restrict electric current flow. Other examples of electric properties. SemiConductive behavior just tells us to say that a material can actually behave as a conductor or an insulator. It can actually be an intermediate between those that conduct or insulate. These substances that show such a behavior are called semiconductors. So by adding chemicals or modifying the temperature, they can actually be managed to adjust their electric conductivity. Then if you look at piezoelectricity, you're just looking at the ability the material has to transfer some waves into sound waves. Now, what I want you to understand is that all these examples of electric properties are what we'll be looking at in details, because when you look at material science and engineering, it's just a course that allows you to understand the properties of a material. I don't really want to go into much of the details that we have. I just want to classify the materials according to these properties that we have. So let's move on to the next aspect. Thermal behavior, from the word thermal, you need to understand that it shows you the response or the characteristic of a material when subjected to change in temperature. Examples of thermal behavior that we have is thermoconductivity. It measures how well a material is able to conduct heat. You'd find that metals will have a high thermoconductivity, while insulators will have a low thermoconductivity. So thermoconductivity will simply just measure the material's capacity to transfer thermal energy through conduction. Just like we have thermoconductivity, we also have what is known as thermal expansion. Thermal expansion refers to a material's tendency to expand or shrink in response to the change in temperature. When heated, most materials expand or contract. We have what is known as the coefficient of thermal expansion, which determines the magnitude of dimension changes that occurs as a result of temperature change. The coefficient of thermal expansion will be explained in details the time we look at thermal behavior as a main topic. Other examples of thermal behavior is the specific heat capacity. The specific heat capacity shows you the amount of heat energy needed to increase the temperature of a unit mass of a material by a specific amount. It will also describe in simplicity the ability of a material to store or release thermal energy. Other related examples of thermal behavior are melting and boiling points. Melting and boiling points just talks about the change of state or the transition of a material from a solid to what? A liquid. Let's understand that. Another example we have is thermal stability. Now, this will refer to the material's capacity to resist high temperatures without decomposing or changing structurally. It will indicate the highest temperature at which a material may be used safely without degrading it. So, what I've mentioned are mostly the examples of thermal behaviors that we have. The next property we need to understand is a magnetic property. From the word magnetic, it has to show you the type of property we're trying to highlight. This would demonstrate how a material reacts when subjected to a magnetic field. Examples of magnetic properties, we have magnetization. It's the ability of a substance to become a magnet, or to display in simplicity the magnetic behaviors that a magnet will always possess. Materials can be classified to be either paramagnetic, diamagnetic, or ferromagnetic. But that's not the only classification we have under magnetic properties. When we look at magnetic properties in details, we'll explain clearly the types of materials we have under magnetization. We have what is known as magnetic permeability, which shows the ability to enable magnetic flux to flow through a material. Other than that, we have what is known as magnetic subsystemity. It shows you the degree or how much of the magnetization that a material can undergo when exposed to a magnetic field. We also have things like the carrier temperature. The carrier temperature is mostly present in ferromagnetic or ferromagnetic substances because it shows you the way a material will behave, in the sense that the temperature at which a ferromagnet or ferromagnetic substance loses its permanent magnetic characteristic is what we define as the carrier temperature. We'll look at it in details as well. We also have what is known as hysteresis. Other people pronounce it as hysteresis. Now, this talks about the lagging or delay in a material's magnetization. This is as a result of a change in the magnetic field. Other than that, you need to understand that we have other behaviors that pertain to magnetic behavior. But for now, we'll just look at these. The next property we need us to look at is what is known as the optical property. Now, this shows you the behavior of a material when subjected to light or any type of electromagnetic radiation. We know electromagnetic radiations are just radiations that are electric and magnetic in nature. So if you look at examples of optical properties, we look at things that pertain terms like opaque or transparent. Transparency refer to the material's capacity to transmit light without significant absorption or scattering, enabling a clear view of what objects through it. Or if you look at the substance that is opaque, or you look at opacity, this describes the material's capacity to obstruct light, making it challenging or impossible to see through. We also have absorption, which describes the procedure through which photons or light particles, as we know, are absorbed by the substance. Other than that, we have the two terms, which is reflection and refraction. And we need to know that this one talks about the bouncing of light, and this just involves the bending of light. Scattering will be explained in detail at the time we look at these optical properties as a main topic. But when light meets with microscopic particles or imperfections in a substance, it changes direction and spreads out in different directions. That's most of the reason why the sky is blue. I'll explain in detail, but that's the reason why the sky is blue and why the water looks blue in most cases. Yeah. So scattering is quite interesting. Be mindful about that. Then on optical properties, we also have luminance. You've heard the term luminance before. When we talk about terms like luminance is where we talk about this property. We're looking at the emission of light by a material after it absorbs energy from an external source. You know, objects will be luminant in some way. So that's literally what it involves when you talk about optical properties. The next property we look at is the deteriorative property of a material, and it's actually the last property that we have. This shows you the behavior of a material when subjected to reactions with its environment. For instance, oxygen is going to corrode. That's why we look at examples like corrosion. Corrosion is just a chemical interaction that happens between a material and its surrounding environment, resulting in a material's degradation. Now, it mostly involves things like rust, oxidation, and other chemical changes that impairs the structure and quality of the material. Now that we know these properties that we have, we need to understand that we have other terms that are quite used or important to understand under material science and engineering. Terms like processing and performance. If you look at processing, you're looking at something that deals with manufacturing and shaping of a material to achieve a desired form. That's processing. If you talk about performance, you're looking at how you're able to assess how well the material performs and how well it can meet specific demands or expectations in its use. But one thing you should put in mind is that every time you're selecting a right material, you should consider three things. One, the in-services, the strength or ductility. You're looking at the properties in short. The cost of the product, how much is it? Is it an affordable choice? The deterioration of the material, how it behaves when subjected to environmental conditions, and so on and so forth. Now, once you understand that, you need to understand that we have 4 disciplines under material science and engineering. These disciplines will help you understand exactly how things move under material science and engineering. And 4 disciplines involve processing, structure, property, and performance. In short, it's known as the PSPP. So this shows a relationship that we have under material science and engineering. So we'll end here in this video. Be mindful of everything we've looked at. We have discussed what material science and engineering is. We have understood what material science by definition is. But we look at the structure and property. Engineering, look at how you can create something. We have understood what structures are, the types of structures we have, the properties, the examples of these properties in terms of how they are grouped according to the solid materials that we have. We've looked at mechanical properties. I've looked at electric properties. I've looked at thermal behavior. I've also looked at magnetic properties, optical properties, and derivative properties. We've understood what processing and performance is, and things you have to put in consideration when selecting a right material. And lastly, the PSPP. If you have any queries, you can always reach me on WhatsApp on the line +260 77 1495252. Remember, slow progress is better than no progress. And remember to strategize before becoming a statistic. Let's try and push for that A+.